Alright, so I recently challenged myself to build a .NET MAUI application in just 7 days. So I wanted to do this so that I could explore more practical .NET MAUI topics. I wanted to create this video eventually so that I could share some of my takeaways and learnings from building .NET MAUI applications. And specifically, I needed an app that I could use for stretching routines. So we have this application. This is called Routini. So we have our routines. We can create routines, we can create any kind of routine, but specifically I want to use this for stretching routines because couldn't find a better app out there. So created my own. All right, so we can create a routine, call this stretch 4. We'll throw some steps in here. So of course a routine can have many steps. You can change the duration, you can add another step. You can also rearrange these steps. So here we go, drag and drop, gotta love it. We got stretch 4, we can play it. There we go, those are routine steps that we added. Let's start it. It counts down. My favorite feature, when it counts all the way down and goes to the next stretch, it actually does a beep noise, which is nice because I don't have to like actively watch this timer. I can just go in autopilot mode with my brain and just go through the routine and just follow the beeps. All right, you can pause, resume, cancel. You can edit your stretch routine. So of course you can rearrange these again. Let's update. We reordered them. So now let's talk about the nitty gritty. So I actually started off with persistence. So how we would save the routine data. So it might make sense to do like a REST API in front of a cloud database, especially for a .NET MAUI application, because in that case, you could have all of your data synced across all of the different cross-platform devices. I didn't really want to do that here because I wanted to keep it simple at first. I didn't want to add more components to the complexity. So I just went with a local SQLite database instead. Specifically, I used SQLite.net, pretty lightweight, simple SQLite ORM. You might be wondering why didn't I use NET Framework? NET Framework I felt like would be a little bit overkill. Also, it's not like I'm ever going to use a different database provider. Like I'm not going to have my mobile application connected to some kind of SQL server out there in the wild. So it definitely felt like this was sufficient. In terms of implementation, pretty straightforward. So I started off creating my DTOs. So we have our routine DTO, then we have our routine step DTO. So these DTOs kind of represent the schema. And then we also have a one-to-many relationship here, of course. So our routine can have many routine steps. And this was kind of weird. So this SQLite package doesn't support foreign keys. So I don't think I could do joins either. So with that, created a SQLite connection factory so that we could connect to our database from anywhere. Also created this database initializer so that we could set up the database on startup and create the tables. This is important. And then with these fundamentals, pretty straightforward for interacting with the database. So we can get our database connection, fetch all the routines, fetch the corresponding routine steps. This link is kind of nasty. I should refactor this. And then same kind of things for updating the routine, deleting a routine, and then creating a routine as well. So insert the routine, as well as all the routine steps. Updates were actually kind of interesting. So for updating the routine steps, I actually found it was easier to delete all of the routine steps first and then create new ones. I actually don't know how else I would do this. Like it would be really weird to target the routine steps and like update them specifically. I think this was way more straightforward, maybe the only way to do it. Who knows? And then of course we're dealing with .NET MAUI here, so comes with dependency injection built in. So I was able to register all of these things in dependency injection and resolve them and use them. So at this point, when I was building this, I really only had the persistence done. I didn't have a UI to test this out. So for testing, I would just go into my app.xamarin.cs and just resolve stuff and then call those CRUD methods accordingly to test things out. And actually, while we're here, this is where we're initializing the database. So just on start, calling database initialize. So that sums up the database part. So at this point, it was time to move on to the UI so that we could have a cleaner way or a sane way of actually interacting with our database. So when I was building the UI, I deleted all of the styles. I was purely focused on functionality and just making things work. And I came back to design later on. So I started off with pages. So I have all of my pages in this root pages folder. I find this as like a nice entry point to understanding the different parts of the application. So I have views and view models for all of the different pages. Of course, we're using MVVM here because MVVM is awesome. Nice separation of concerns, binding rocks. So let's dig into this list routines view. So this corresponds to that first page where we list all of the routines. So we have our heading for our routines, We have a button to go to the create page. And then, oh, I forgot, we are using our XAML if statement. I have a video about creating this, but this is just a useful tool for conditional rendering. So if we're loading, we show a loading indicator. If we have an error, we show an error message with a try again button. If we don't have any routines, we show a message for that we need to create a routine. And then finally, if we do have routines, we show our collection view of each routine. And then to do that, on our view model, we have to load up those routines. So we have our routine query in here. So this is what calls the database and loads the routines. Again, we're using dependency injection, so we're injecting that query. And then we have a method down here to load the routines. So just fetch them through that query and then update our collection or observable collection of routine previews, which is what gets displayed on the UI in our collection view. So you might be wondering, how does this load routines command get called? What the heck is going on here? So first off, we are using the MVVM toolkit. So the toolkit is an MVVM helper that helps reduce boilerplate for MVVM applications. I'll link a video about the toolkit somewhere if you're not familiar with it. So in this case, this relay command attribute turns this load routines method into a command. So we can actually see we have a load routines command, which we combine to in order to execute this command logic. So in the past, I would do something in the constructor and just take that command and execute it, but I didn't do that here. And the reason I didn't do that is because these view models are essentially singletons. So whenever you land on the list routines page, it would only call this command once if we were calling it here, which means if we created a routine and then came back to the listing page, it wouldn't have the new routine. So alternatively, I created my own sort of view model lifecycle behavior. So if we go into the view in the code behind, I added an on appearing command. So if we leave this list routines page and then come back to it, it'll re-execute on appearing and call this command, in this case, to reload our routines. So we can see in the list routines view, we are binding the on appearing command to our list routines command. So we can see that in action. So here we go. We show the list routines page for the first time, and that loads our routines. So now if we leave and then go back, on appearing gets called again, and we re-execute our on appearing command. So that was my solution for view model lifecycles. I couldn't find any information about this on the internet, so I'll definitely be creating a video talking more in depth about this solution here and the reason I ended up needing it. So that handles the pages. All of these other pages kind of followed the same pattern where I would implement or import my database queries or mutations and then call them. I should also talk about routing. So if we go into our app shell, we can see we do have a route in here. So I actually only have the list routines route in here, and the other routes are in the code behind because I wanted to register these as nested routes. So these are under the routines level as these sub-level routes, and this is key for nested or relative navigation, I think it's called. So for example, on the list routines page, we can do this relative navigation instead of, for example, absolute navigation. And since we're using relative navigation, we get this back button automatically at the top, which I find useful. Also with routing, I had some routes that needed query params. So for example, the routine detail page. So I had to implement iQuery attributable and then implement apply query attributes. So that would take our query parameters. And in this case, I wanted the ID of the routine that we wanted to show details for. So I would extract that, query the routine, and then update the view model with the correct routine data. And then passing these query parameters, super easy. I actually have an example down here. You just pass in after a question mark, the key, and then the value. All right, so some other fun topics were components. So for example, I had this create routine page and then an edit routine page. And overall, they use the same exact form component. So we even see that on the UI where like the create form and the edit form are basically the same with like minor differences. So I extracted a routine form view model. Let's actually see where that is. We have the routine form view model, which has all of the reusable form stuff and a corresponding view component as well. So that was helpful for reusability between the create and edit forms. So keep that in mind, extract components if you need reusability. And while we're in with forms, we can talk about validation. So leverage the MVVM toolkit here. So have this observable validator that we're inheriting from. So this adds iNotify property changed, but for validation, it also adds iNotify data error info. And then even better with the MVVM toolkit, we can just add these validation attributes to our fields. And that's pretty much all we have to do for validation. I also have these helper properties here for actually getting the error message, which we show on the UI here. So if we have an error message, we show it. Let me actually demo that. So for example, if we don't have a name on our step, we get this required error here. Same thing, validation in other places. I think we have one on the duration as well. So yeah, it must be greater than 0. This was a really annoying bug that I ran into. We'll talk about this later on because it's actually still happening. Another cool concept, and that was the collection view form input. So this is the collection view for all of the routine steps on the form. So just binding to an observable collection with the routine steps from the form. I also have this special form view model that holds all the data and has its own validation. So we kind of have some nested validation here, which is interesting. So yeah, when we submit, I also call validate on all of the different routine step view models. And yeah, I just thought that was interesting. I've never done a form that had like a collection on it as well. So definitely some interesting scenarios to work with here. And part of that was drag and drop. So I was really nervous about implementing drag and drop because drag and drop is usually really hard. But literally all you have to do in .NET MAUI, if you're using a collection view, is add can reorder items to true. And that's it. It enables drag and drop. And that's how we get this on the UI. That's all it is. And actually I do have this drag icon here, but you can drag from anywhere. Doesn't really matter. So yeah, quite magical. So I think that covers most of the UI topics. Again, at this point in the beginning, I was really only focused on functionality, didn't do any styling. So that being said, we'll talk about design and styling and all that other fun stuff in a little bit. So at this point, the application was starting to get bigger. So I did some refactoring and ended up with vertical slice architecture. So I have a whole series on vertical slice architecture. No, I didn't invent it, but I do like it and use it quite often. So at the top, we have all of our pages. Talked about this earlier. This is like the entry point to understanding like the high level of the application. We also have all of our different features. So this covers all of the different use cases that our application supports. Of course, the key thing with the vertical slice architecture here is it's cohesive. So everything related to creating a routine, deleting, editing, listing, playing routines, it's all grouped together and will change together and is easy to reason about. And then finally, we have our entities. So we just have a routine in this application. That's all this application's about. And that includes all of our routine stuff. So just wanted to show that off because vertical slice architecture is awesome. It's a little bit hard to get right. Definitely takes some experience, but the benefits are great. Again, I talked about cohesiveness, and it's just easy to understand how the application works or what the application does just from the folder structure. Of course, totally fine if you're not into vertical slice architecture, but if you're just seeing this and this seems interesting, check out my series on vertical slice architecture. Okay, so we've talked about connecting to the database and adding functionality to our UI, but at this point, the application didn't actually do anything. So we had routines, but you couldn't play a routine. And this is where we got into our domain logic. So of course we had our routine domain object, but I needed to be able to play this routine and make it do something. So at first I actually ended up adding a bunch of stuff to this routine class. So I added like a timer to play through the routine, added methods to like start and stop the routine, but I ended up extracting that to a wrapper class. So we have this playable routine because I felt like there was just so much complexity in here. I wanted to kind of pull this out since not every routine in our application needs to be playable. Because for example, some of these routines are just shown in the list view or are used for editing. We really only needed to play a routine whenever we were on the play routine page. So this captures the routine timer, all of the different state of the routine, and then methods to interact with the routine, and also events for routine changes. So whenever the routine was updated or the step changed, we fired events for that. And that was really key at the view model layer. So for example, I would subscribe to these events. So whenever a routine updated, I would update the UI. So for example, this is how we got like the countdown timer functionality. Since as we can see here, we call on property changed for the current step seconds remaining. And then we also subscribe to the routine step changing. And this is where we would play a sound to signal the end of the routine step. So we are packaging this ping.mp3 into our application. So I think resources, raw, here we go, ping.mp3. And then to play this audio, we are leveraging, what is this called? Plugin.maui.audio. And this worked out perfectly. So I don't think I've demoed the sound yet. Let's see this in action. All right, here we go. Hopefully it's not too loud. Be careful. There we go. Yeah, next stretch. So with that beeping noise in mind, one thing I noticed is that if we played the routine and then left the page before the routine finished, it would still make that beeping noise. So essentially what we had to do was dispose the routine whenever we left that page. So tapping back into the view model lifecycle stuff that I talked about earlier, I added an on disappearing command to the routine detail view. And then whenever this view disappeared, we would call that command. So in this case, I linked that command to a dispose routine command, which would of course dispose our routine and make sure that beeping noise didn't occur. So that was a fun little discovery and kind of shows off the need for these view model lifecycle methods. So at this point, all the functionality was there. We were saving our routines, we had domain logic, we had our pages, it was all ready. The only issue was that things looked really ugly because I had no styles, so that led to design. So in the past, I was really, really bad at designing things. Like I would build the ugliest applications. Even some of the older things on this channel are really ugly. I still don't build things that are really pretty. Like these designs aren't anything to rave about, but they're better than what I had in the past. And one thing I learned to like get a little bit better is that you have to design things in Figma or some kind of design tool before diving in. So created these designs in Figma, added some edge cases here. This handles all the pages, and this pretty much matches up with what we built for the most part. So can't complain, pretty satisfied with how the styling turned out. So in terms of implementation of the design, I just created styles in my root app.xaml. So again, just global styles. Did a little bit of style inheritance, so I had a base button with some different button variants on top. Nothing crazy like I've talked about in other videos. Didn't feel like it was necessary to have like an actual button component. I got by just fine with styles. I did bring in a custom font. So I brought in Inter, which is like becoming an overused font, but kind of like it. So I registered that in my Maui program.cs. One thing that I found really annoying is that there's no way to really set like a global font. You have to actually set it on each of your different elements. So I added it to labels and buttons, and I guess that covers everything. I probably need to add it to entries as well. So I missed that, I think. So that's kind of annoying that you need to add this to like each of the different elements, and you can't just set like a font family at the root of the application that automatically gets applied to everything. Continuing with design, I also added icons. So for example, we had this drag indicator on the routine steps. And for this, I used Maui icon. So this was actually a package. So here we go, Maui icons. And you can bring in a bunch of different icon variants. So I think I'm using material icons. Yeah, here we go, material. So definitely check this out for icons. This was super easy to use. And now that I think about it, probably could have added more icons throughout here. So after design, that was pretty much it. The application worked and I was satisfied. But I did want to explore more topics for like enterprise.NET MAUI development. So the first thing, or probably the biggest thing, was testing. So I added a test project. This was a little tricky to set up. So tests and .NET MAUI I've always found a little tricky to set up. I have a whole video on, I think, integration testing with .NET MAUI that I'll leave a link to, because that goes into some of the intricates that I discovered here. I think the biggest challenge is that you have to add NET 8.0 as a target framework to your .NET MAUI project. And then you also have to make sure that you only output as an exe when the target framework is not NET 8.0. And this makes sure that whenever your test project builds your .NET MAUI project, it builds it as a DLL that can be used for tests. So that worked out well. And as you can see, we have a bunch of tests down here. I really only went with integration tests. For instance, I have this mock environment, which creates a service provider that pretty much matches what our application uses. Here we go, it actually references the same services that we register in our app. But most importantly, it replaces things like the database connection with an in-memory database, and replaces other things for the sake of tests, such as the date, and timers so that our tests aren't brittle and dependent on certain times. And most importantly, since we're only mocking the boundaries of our application, it's like the database connection and time and timers, it makes our tests really powerful and not brittle. Our tests really represent how our application is used. So for example, the create routine test, we bring in our list view model and our create view model. We load our routines, make sure the routine listing is empty. And then on our create view model, we fill out the form and submit it to create a new routine. Then reload our list of routines and make sure the routine was actually created. So like this one test gives us so much confidence in how our application is actually working. And then I went ahead and did this for other use cases as well. So updating routines, same kind of thing. Also added helpers to our mock environment so that we could initialize it with certain data. And then testing list routines. So here we go, initializing our data again, and then making sure that data loads on our list view model. And then even have a test for playing the routine. So this one's cool. So we add a routine to our environment. We view that routine on the routine detail page. And then we're mocking the start time to right now. And then we start the routine, make sure the routine did start and shows our first routine step. And then we actually mock our time to be 16 seconds ahead, which would signal that we need to move to our next routine step, which means we can assert that the routine actually advanced to the next step. And we do that a few more times until we make sure the routine completed. So really satisfied with how these tests turned out. And again, I have a whole video on setting up integration tests in .NET MAUI. So definitely check that out if you want to write some powerful and not brittle integration tests. So at this point, the app was complete. We had tests so that we could deploy with confidence. So all that was left was cleanup and getting ready to publish. So of course, every app needs logging so that you can actually debug production issues. So added serial log, and in this case, we're writing to a logs.txt file. And then also set up app metadata. So we can see in our app shell, we update our window title to be routine. Then in our CSproj file, we update our app name to be routine as well. And finally, I added my own app icon. So if we go to your resources app icon, we can't preview it here, but it basically looks like this. So I created this in Figma. So these are arrows to represent a routine. And then they kind of look like noodles because I named the application routine. That was what I was going for. I don't know if that makes any sense. I actually don't know why I called it routine, but sounds cool. At least I think. And then at this point, we're ready to publish. So I created a deploy workflow with GitHub Actions. So I have a whole series on CI/CD topics with .NET MAUI, and that series covers more advanced things like automatic versioning and automatic updates and creating GitHub releases. But for this example, I kept it pretty simple. So we just have this deploy workflow here that does a plain old .NET publish and it uploads it as a build artifact. So not getting into creating GitHub releases or doing auto updates, but I feel like this was sufficient because from here we can install the application. So if we go to GitHub Actions, here we go, we have this deploy workflow and we have our build artifact. And I'm actually publishing this for macOS 14. So I would really prefer to have this on my phone, but I don't have a phone that I can install apps on right now. So at this point, my MacBook works for me because I can at least move that around and take it with me to stretch. So that covers the process of building this application. For the most part, it went pretty well. I was pretty satisfied, but there were some struggles along the way, some that I resolved and some that I didn't. So probably the most annoying one, and I alluded to this earlier, is with collection view spacing. So for example, if we have validation errors here and we show this error message, whenever we add these error messages to the screen, it doesn't resize the collection view item and make it take up more space. Instead, it just overflows and the content clips off the screen. So definitely not ideal. And I think I even saw a GitHub issue where other people were talking about this. Another issue I had, and we're seeing it right now, is that every like 4 or 5 times you start the application, at least in development mode, it would just show a blank screen, which is really annoying. Because when you're making changes and building and starting, sometimes it takes like 4 seconds to actually boot up. So you wait those 4 seconds and you get a blank screen. Kind of annoying. I also already talked about the issue I had with global fonts. So that was a little strange to me that there's not a way to do that. And the last struggle I had, which I did find a solution for, was the view model lifecycle stuff and activating or deactivating view models. So it just feels like this is something that should be supported in .NET MAUI by default. Like there should be some kind of hook somewhere to hook into the view model lifecycle. Or even better, if I register a view model as a transient, it should actually act like a transient, which it doesn't. So for example, when we boot up the application, it'll initialize this view model, which makes sense. But then if I leave this page and then go back, it doesn't reinitialize the view model or create a new instance, even though I've registered this view model as a transient. So it's like the app shell kind of holds on to the view model and only initializes it once. And just to clarify, this also happens if the view is transient as well. Same thing, only initializes it one time. So if we go back, same kind of thing. So yeah, maybe there's better ways to handle view model lifecycle stuff, but I do feel like it would make sense for transient registrations to actually act transient. So aside from those issues, there were some things that were really awesome. So of course, navigation with the app shell is really easy to do. You just register your routes and then say you want to go to them. Can't complain about that. Much easier than it was in WPF, where there was really no built-in navigation support, and you either had to roll it yourself or use a framework. As always, other highlights, the community toolkit makes things really awesome. Can't emphasize that enough. And the other big highlight was drag and drop, how easy it was to implement, or really there was no implementation. At least for collection views, it's easy. With other kind of drag and drop, it's probably a lot more advanced. But still, this was a nice touch. So on that note, is .NET MAUI perfect? Not necessarily. There's still some flaws, still some bugs. So it tempts me to try out Avalonia or Uno for comparison. I haven't tried those out yet, so can't say much about them and can't say much about MAUI in comparison to them. And of course, this wasn't the craziest app, not super complicated, but in terms of .NET MAUI, I had a relatively positive experience, I'd say. So on that note, hopefully you can apply some of these concepts to your own .NET MAUI application. And for reference, all the source code is going to be in the description, and all the videos that I've self-plugged along the way will also be in the description. And also, this was more of a high-level overview, so if you have any questions about this application or want to learn more, definitely leave a comment below.